Hey everybody, you've made it to the last project. It's the S60-101. So the part with the lowest part number comes last. This is the cam for the primary cylinder. It does culminate all of the skills you've done so far in the class into one part. So I chose this to be the final part, kind of the test of your ability to apply both mill and lathe toolpath to a part. And it's going to require a minimum of 3 setups. We are going to rob some toolpath from a similar part, of course, because that's what's efficient. If we go to Solidworks, I have the dash 131 right next to the dash 101. The groove pattern is identical. I have them zoomed at different scales, but the dash 131, if you remember from the assembly, sits down in this pocket. And this groove spacing is actually the same. You can't really tell unless I zoom out, and it is a significantly smaller diameter. So all of these exterior features related to the grooves, we should be able to take that information and more or less copy this over. Now we have a lot more going on with this other part, so we will need to add to it. So open up both your parts, your 101 and your 131, and go over to the cam tab on both of them, and we're going to highlight the one job in the 131 since it was a single operation part. We're going to right click on that, and we're going to copy and come over to the 101 and paste that. Okay, so let's go ahead and close our 131. I'm going to go ahead and save it just in case I did anything wrong. And then we can maximize the part we're working on, which is the 101. Now, of course, first thing we need to do is change names, or we're going to be running the wrong part. It's still 101 op 1, or it's still op 1, but it's the 101 part. All right, let's go set up our job for this piece of material. Yes, we know we need to regenerate because that's what we're doing. Okay, we get a default cylinder. It is turning and milling. We want to change this to the 101. It's not turn complete, so we're going to type op 1 for the lathe. We really only have one lathe operation, and we're going to have 2 milling operations for this part. Okay, we have cylindrical stock. Our cylinder, we need to select something in the same axis as the cylinder. So we're going to pick this. I'm not sure why I've lost my cylinder view. Okay, now our origin's pointing the wrong way, so again we got to fix that. They should have put that next and then add the stock, but that's why they have it set up. I'm going to go down. We don't want model front. We do want model front, but we do want to set our z-axis and x-axis, so our z-axis is going to be in line with the face, so our coordinates turned. And we forgot to do something. We're going to be using some of our sketches, probably most likely, so we want to make sure that our sketches are visible for the primary feature. It looks like in this case I revolved everything and did the ribs as a separate feature. And what that does is it allows us to simplify the exterior turning to take this down to diameter before we come in and do the grooving. And then we have all our interior features. Now it's possible you may have modeled in a different sequence where the interior features were made as a revolved cut. If that's the case, you're going to use that sketch as well and switch between them. For demonstration purposes, I elected for this demo to revolve the whole thing because we're not learning how to do CAD, and so you have to bear with me if there's some differences in what you're seeing in this sketch and your sketches. So you may have 2 separate sketches that involve what I'm showing here. If you do, your first sketch is just a rectangle. Not a problem, we're going to use it. What's important is that your x-axis is in the same plane as those sketches. So it's something to think about too when you're modeling. You make life easier on yourself if you use a consistent scheme for your sketches. You could have easily made this revolve cut in a different plane, but now when it comes to machining, you've got to do a completely different setup for anything you're going to reference on that. Okay, so we got that taken care of. Everything's pointed the right way. We don't need to flip the x-axis. Let's go up to stock, and we got cylindrical stock. Our finished diameter for this part is 1 inch, and the material that was purchased for it is 1 1/8 inch diameter. So we need to put a radial stock offset of 0.06. Actually, it's going to be a 1/16. 1 divided by 16, because that's half of the extra diameter. Somehow my model is no longer selected, so make sure your model's selected. Okay, so I've got reflected a 1/16 of extra stock, and if your model, I don't know, I just selected it somehow. Okay, and then on the front side of the stock, we'll just leave the same. We're going to go 0.01. Our backside offset's going to be 2 inches, and we're leaving 400 thousandths to stick out of the chuck. So that's consistent with how we cut the 131. Alright, now once you have all that set up, we're going to scroll down and we need to change this to the 101 1 and 101 first op. Okay, we're good there. We're going to hit accept. Okay, so we have a significant amount of material to take off the outside diameter, which is fine. I'm going to suggest we face it. We do all the work on the interior. That way the part is its maximum mass for heat, is absorbing any heat that goes into that. We obviously don't have this hole going to be present in the part. Okay, so I'm going to suggest we start off doing this in more or less the same sequence we did before. And then after, when we get to this drilling routine, we're going to start doing the interior features. So we'll have a different series of drill bits here. And of course we'll do the parting at the end. First, we're going to regenerate the facing operation. That should pretty much carry over. So we can edit that. Yeah, 40 inches a minute's a little fast, but. And then we go to the next tab. There's nothing really to do there. And then we can go to the diameters. It's going to base it off the new model, so those should be all set. And we do want to use wear offset whenever possible. And we'll keep our lead in and lead outs as we did in the other part. Okay, so it zips down to the center, and we should have the face machined down. Okay, now we're going to go to the turn of the profile. We go edit. We're going to see if it'll accept it off the model. If not, we're going to need to use our sketch. Okay, so we're using our outside diameter turning tool. That's fine. We're going to go to geometry. Looks like we had some confinement, so we're going to confine off the front face, and I'm guessing was the back face. So it's confining the cut, and the intention on that is to overcut so that when our parting tool comes in, we don't have to remove all the diameter to do that final cut. Alright, so we're moving on, moving to the next step. Pretty much all of this information should update from the old model. And if this interrupted cut doesn't give us hell, this should work as long as we have don't allow grooving. We're going to do wear compensation, and now we're going to go to the last tab, and hopefully we can leave those settings the same. So let's hit accept. Alright, so we got a single rough cut that comes in, a single finished cut that comes in. So in this instance, we didn't need the sketch, but it's always good to have it available if you need it. Alright, so we've now turned the face and the outside to finished diameter. It's a good thing to check the part at that point. So if your diameter's off, you've already scrapped the part. It's a good point to stop the machine and just double check your tool settings, or check every 5 cycles or so, because we don't want to put more work into this workpiece if we've already gone out of tolerance with this. Okay, so we have our single groove, and that's for the grooves on the outside, and I believe we have more of them than we did last time. So we're going to go edit, we're going to reselect our grooves. So we're still using the 1mm grooving tool, our geometry, so we need to select our grooves. So we're going to select the leading edges of each of the grooves. I'm going to select the leading edge, or the leading edge of each of the grooves, which should put our tool in the correct place. So there's our grooves. And we're going to keep the alignment to the back of the cutter, and we're going to go to our diameters, and it's asking what's the inner radius. So the inner radius, you can just select any of these cylinders and it should work. And then we're going for model OD because we've already turned it down, and in diameter. Okay, we're going to leave that at default and leave the last one at default. Now we hit OK, and we should have a series of cuts. And if you have it offset to the correct side, it should match what I've got here. Okay, so at that point, what you're going to have is this part up to this point with grooves on the outside. All right, moving on. All right, so we have a series of holes to do. Now, all of these, pretty much all of these inside diameters are going to be first pilot drilled, and then we're going to come through and do boring operations. And it should be hopefully a little easier on us this time, because the boring, there'll be significantly more room for the boring bar to fit in here. Okay, except for this last pocket. It's going to give us heck because there's not a lot of room. But we resolved it on the 131, so we should be able to resolve it on this one. Okay, we're going to go to the spot drill. We want to do our spot drill as deep as we can, but the spot drill is a 1/2 inch in diameter. Evaluate, and we're going to measure what our largest diameter is here. It's 652 thousandths. So it's really not going to matter. We're not going to end up making a chamfer that drill bit can use. We're going to be using a smaller drill bit first for clearance, but I wouldn't go significantly deep with the spot drill just to try to accommodate this, because the reason is to go deeper is to create a leading edge chamfer. So we're going to go with the spot drill, and we're going to go edit, and we'll zoom out a bit. As you can see, it's smaller than the largest hole. To achieve the chamfer, we had to have had a larger spot drill, like a 3/4 inch. Okay, so let's just select the first hole. That's going to be enough. We'll go to the next tab. So right now we have it going 100 thousandths deep. That's probably more than sufficient. In fact, that's a little much. That was for the 131. We don't need that much to just start the drill out. So let's go 0.06, 60 thousandths deep. And again, that's got to be a negative number. And go to the next tab. We leave that at default. Okay, we hit accept, and we have a center drill that's should be sufficient for the next drill bit. Now there's two approaches we could take with this next drill. We've selected a drill that's intended to go down all the way to here to drill out this bore. We could start with that smaller drill and go the full depth. It's going to take a significant amount of time. Or we can just go in with the larger drill that we're using to core this out, and then come down and do one more drilling routine down in the center here. I'm going to elect for the second plan, because I don't want to wait for the time for the smaller drill to come in and center drill. But we'll go ahead and recycle this drill routine because we've got it. We go to edit. Yes, we're going to switch drill bits from our library. We're going to the mill library this time, and we're looking to select, I'm sorry, we're not. We're going to the lathe library, and we're looking for the second to largest drill in the index. I believe we selected this 562 drill, the 9/16 to do that job. So select the drill, and we're going to increase the feed rate on this one. And we're going to select our hole features we're going to drill with this. So what we're going to drill is this. And we want to make sure auto merge is selected. We'll pick this bore. We're going to pick the next landing, and then we're going to pick the next landing. And that's where we want to end. Now this auto merge should merge it all into one hole location. Okay. Now right now it appears we're drilling way too deep. Okay, so we've got our features. We're going to go to the next tab, and we do not want to break through with the drill point. So we're going to select do not break through. We want it to end where this last floor is. We'll go to the next. Pec depths, we can definitely do a lot better than that. So our pec depths are going to be, so our tool was 9 divided by 16. Okay, which is 562 thousandths 5/10, and we'll divide that in half. Now with this larger diameter, you probably could go more, but what I want to do is I want to clear the brass to make sure it's not damaging the inside and galling up. We should be able to accept that. So we should have a cut that looks like the orange profile. And we want to remove the material in the smaller hole because that's actually going to remove some of the floor of the bigger drill bit that's already gone in there. Copy this or duplicate this tool path, and then we're going to recycle it. We're going to go edit. Okay, we're going to go from the library, and we're going to find the drill bit that we selected, pre-drill the 234 to 36 hole. And it needs to be bigger than the boring bar that we're using. So I believe we chose the 199 drill to do that job. Number 9 stub drill. And that was the compromise between the part and the dash 131, which now I'm realizing is the diameter we just overwrote. So for this part, oh well. Okay, so it's going to be a little hard to see with the tool holder in the way, but okay, so it's tool number 11. We're going to go to what are we drilling? We could select all of those, but then we're going to end up with a feed rate all the way in there. So this is going to get a little bit on the scarier side. We're just going to select the one hole that we're working on. And since we've cleared out all the material around it, we don't need auto merge. We don't need to clear out all the material around it, nor do we want to peck in and out a lot to get to it. All right, so here's where the retract heights come in. So we've got a clearance height. That's from the retract height. Retract height, we don't want it, so it's going to be at model top. And our feed height will also be at model top. Now we could set that feed height way down here. Machine will wrap it inside the part to that point. What we need to do is change this to model top, and that'll back that plane up to the outside of the hole. So any movements in are going to be at whatever feed rate we programmed it at. Okay, and then our actual cutting is going to go from hole top, which is fine, and we're going to go to hole bottom, and we do not want to break through because we are going to bore this out. Okay, now we're going to go to the next step, or pecking depth, Again, we picked a 199 diameter drill divided by 2, gives us about 10,000 steps. And you can see it's still significantly smaller than the finished bore. Okay, we're going to go ahead and hit accept. And there's our drill bit. So the pecking will be reduced to here, but it's still going to feed in all the way.